An observer notices that an airplane flies directly overhead. 2 minutes earlier, 2 minutes later, the plane is at an angle of elevation 27 degrees. Assuming that the airplane is traveling with constant speed, what will be its angle of elevations after another 2 minutes? Okay, so the situations look like this. An airplane is over here. Yes. Let me draw differently. And this is the first 2 minutes. This is the first 2 minutes. And this is another 2 minutes. Another 2 minutes. Okay, now you are here just below the airplane, or below at least the of the airplane. You are here and you're standing here watching everything carefully. Okay, so now from where you're standing to the point here, you have an angle of elevations. Okay, from the point here, you have an angle of elevations 27 degrees. And
Sir?
the question, yes?
Why are there two minutes?
Pardon?
Why is there two minutes?
What do I know? This is 2 minutes?
No, like that's 2 minutes and also 2 minutes, right?
Yes, the first 2 minutes causing us to have the angle of elevations 27 degrees, which is this one. And then after another 20 minutes, we will be asked later on, so what is the angle of elevations now after you have seen another positions of the airplane? Now the airplane is here. And the question is, what is your angle of elevations right now, theta? You get it, the questions?
Yeah.
Yes. So you may try for 1 to 5 minutes. Any suggestions, Nicolas?
No, sir.
No, sir? Okay. What is the questions again? The question is, what is the angle elevations of theta, right? Yeah. Can I start from theta first? Yeah. So I'm going to try to find the angle of elevations by using this picture. Okay. So I'm going to think like, okay, I have this triangle. Okay. Can you see the triangle?
Yeah.
Yeah. You can use this triangle if you want to, or you can use another triangle. For instance, I'm going to have another triangle. Which one is it? The biggest one here. So I prefer to use the bigger triangle, this one. Can you see it?
Yes, sir.
This one. Yeah, I use the bigger triangle. Let me call it the triangle. Let me call it as A C triangle. Now, I will write it here, the ABC triangle, the ABC. From the ABC, then I can know that my angle theta can be calculated using, for instance, this height and the length, 2 meter and 2 meter. So I will calculate using tangent. Tangent theta is equals to the height divided by the distance in the first 2 meter and the distance in the second 2 meter. Is it okay? So I'm going to calculate it S1 plus S2. So far, so good?
Yes, sir.
All right. Now, tangent theta is not known. H is also not known. So I think H divided by S1 and S2. And S1 and S2 in physics is the same like saying, okay, I have the velocity times 2 minutes, right? So if I want to know the distance is just velocity, the distance here is just velocity or speed times the time taken, which is 2 minutes. And this is also the same because it has the same time and the same speed. So this will be velocity or speed times the time. So I'm just going to write it as 1 and S2, actually as 2S. And this is height over the height over 2 times velocity times t. Or I can stay in this case first. Okay, so I can also just write 2 1/2 times h over s. So far, so good, brother? So that's my tangent theta. Am I right?
Wait, sir. How did you get 1/2 times height over speed?
Well, first of all, I have this tangent theta. Let me repeat again. So I will erase everything. Let me repeat again. So do you understand that tangent theta here is the distance of height, which is this one, the height, which is this one, divided by the whole s, the whole distance. And the whole distance is S1 plus S2, right?
Yeah.
Yeah. And now we get information that S1 will be traveled with a constant speed. And this constant speed is also used in order to get the S2, to travel S2 with the same constant speed, What does it mean? It means that S1 is equals to S2, right?
Yeah.
Is it clear?
Yeah.
S1 is equals to S2. So I can therefore write this tangent theta to be H divided by S1 still S1 and S2 I'm going to rewrite it as S1. Is it clear?
Yeah.
Yeah. So altogether means that my tangent theta is just H divided by 2S1 or 2S1 in this case. So far so good?
Yeah.
All right. Now, having given that, I'm going to shift our directions, our concentrations in another triangle. Which one is it, Sato? This one. I'm going to look at ABD. ABD. Can you see the triangle, the new triangle ABD?
Yeah.
This new triangle ABD. So I'm going to open again a new page ABD. So I'm going to draw something again. So this is ABD. This is 27 degree. Just like here, 27 degree. This would be 27 degree. And here is also 27 degree. And do you still remember what the distance is here? This is the distance S1, right?
Yeah.
Yeah, and this one is the distance of height. Remember?
Yeah.
Okay. So now, I'm going to write tangent 27. Can you help me? Tangent 27 is equals with tangent 27 degrees, height over
S1.
S1. Okay, height over S1. Please compare now our tangent theta, which is height over S1 divided by 2. What relationship do you have now between tangent theta and tangent 27 degree?
Tangent theta has 2 S1, tangent 27 only has 1 S1.
That's right. Tangent theta is equals to 1 over 2 times h over s1, which is actually this one, right? Tangent 27 degree. Am I right?
Yeah.
Okay. So we are almost there. What we are asked is theta. So theta equals with arcus tangents from a half of tangent 27 degree. So let us calculate using our calculator. A half times, so arcus tangent of a half times tangent 27 degree.
The answer is 14.29.
14.29 degree.